In this video lesson of class 12th physics, we will learn about the capacitance of the parallel plate capacitor. We have seen the different types of the capacitors, and this parallel plate capacitor is the most commonly used capacitor. So let us see its capacitance without the dielectric medium between the plates. Here it is capacitor, uniform electric field between the plates, area of the plates A, common area of the plates, and they are separated by D. No dielectric medium, only air is between the plates or the vacuum is there. We know the electric field in the region between the plates is given by sigma upon epsilon naught, where sigma is the surface charge density of the plates. If A is the area, then surface charge density is, how much? Q upon A. So the potential difference between the plates of the capacitor is V is equal to E into D, considering the E uniform between the plates over the distance D. Then we have this formula, V is equal to E into D. If C is the capacitance, then we know C is equal to Q upon V. V is E into D. Putting the values, we will have the capacitance as epsilon naught A upon D. So it is clear that more A, more will be the capacitance, less D, then more will be the capacitance. That's why the plates are kept close to each other. Now the parallel plate capacitor with dielectric slab. Dielectric slab, that is when kept between the plates of the capacitor, that is in the external field, then it gets polarized, right? So dielectric slab of the thickness, let us place between the plates less than the D, separation of the plates. Let the T, thickness of the slab, be less than D. Molecules in the slab get polarized in the direction of E naught. So EP is the induced electric field opposite to E naught. So effective field inside the dielectric will be E naught minus EP. And if V is the potential difference between the plates, then we can have V is equal to, for the air, E naught into D minus T. Air will be in the region D minus T. D is this whole, this is T. So this portion, this and this is going to be how much? D minus T. And for the dielectric, E into T, where E is equal to E naught upon K. We are familiar with this. Definition of K is E naught upon E, called the dielectric constant or relative permittivity of the medium. So we will have this. Let us take E naught common. So we will have this expression. And if C is the capacitance, then we know C is equal to Q upon V. We will have this term. This shows that the capacitance increases with the dielectric slab. Right? K is always more than 1. So you will have to subtract something from D. So effective D, this whole is the effective D, will be less than D. Right? So less than D means C will be more. Now for if T is equal to D, that is in the whole space, the plate is placed, then we will have from here C is equal to epsilon naught K by D. Of course, this is equal to this much is equal to C naught. So we will have K times the capacitance when there was no dielectric between the plates.